This video is on solving systems of equations by substitution. This is part one of two videos. Um, and I just want to really quickly talk about the name of this method. It's called substitution. So, for example, if you have a substitute teacher or a substitute in a sporting event, these people are replacing the original people but performing the same job. So essentially, when you're doing substitution, you are um, replacing something with something that's equivalent to it. So let's take a look at the first example that we have here. It asks us to solve the following system of equations. And we have 2x plus 3y equals 14. Notice we have two variables here, so it's not possible for us to solve this equation with two variables there. But we also are told that x equals 4. And when x equals 4 is given to us, that means half of our work is done. We found out the half of the point of intersection where these two lines will intersect with each other. Because remember, a system of equations solution is a point that satisfies both equations. So I'm going to take the first equation which is given to us, which is 2x plus 3y equals 14. And I'm going to go from two variables down to one by replacing or substituting in what we know is equivalent. So we know that x equals 4. So instead of 2 times x, we now are going to have 2 times 4. And then I'm just going to copy the rest of the equation down how it was before. Plus 3y equals 14. So 2 times 4 is 8. 8 plus 3y equals 14. Okay, now in order to solve this, I need to subtract the 8 from both sides. So the 8's will cancel each other out right here. So I end up getting 3y equals 14 minus 8 is 6. Then I just have to divide both sides by 3, which means that y is equal to 2. So now we know that since y equals 2 here, and x equals 4, the point of intersection where they will intersect with each other and the point that satisfies both equations is 4, 2, where x is 4 and y is 2. In the next example that we have here, we want to solve the following system of equations. Our first equation, 2x plus 3y equals 14, is still the same. So I'm going to go ahead and write that down. But this time, the x equals 2y, we don't actually know how much x is equal to, but we do know that it's equal to 2 times y. So the process is still going to be the same. We're still going to do the same idea. Instead of x, I'm going to replace it or substitute again, because x is equal to 2y, it's equivalent. But this time I'm going to replace it with 2y. And I'm going to put it in brackets because I want to make sure that it is 2 times all of this 2y and not just 2. Okay, so now all I have to do is just keep solving. So 2 times 2y is 4y. And then I copy the rest of the equation down, plus 3y equals 14 right here. So 4y plus 3y is 7y. So 7y equals 14. Divide both sides by 7, and I end up getting y equals 2. So again, I know what y is this time, but I still don't know what x is. So my next step here is to solve for x. So I know here we are told that x equals 2y. So I'm going to start by writing x equals 2y right here. But now we actually have solved for y. We know what y is. We know y equals 2. So I can, again, substitute that y right here with the value of 2. So here we can say x equals 2 times, I'm going to replace that y with a 2 right here, which means that x equals 4. So now that we know what x is and we know what y is, we can say that the value that satisfies both equations is 4, 2. Okay, our last example that we have here asks us to solve the following system of equations. Our first equation is still the same. It's 2x plus 3y equals 14, okay? But now the information that we're given about x is a little bit more complicated than the first two examples. But again, the process is exactly the same. X is equal to 5y minus 6. So what I'm going to do is I'm going to still substitute in what is equivalent. So we know that x is equal to 5y minus 6. Now you have to remember to put this whole thing in brackets or in parentheses, because if you do not, then you're not replacing x with the entire thing that x is worth right here. So what I'm going to do is I'm going to copy everything else down. So instead of 2 times x, I'm going to do 2 times 5y minus 6. Again, don't forget your brackets, plus 3y equals 14. Okay, now I'm going to solve this like a normal equation. So I have 2 on the outside of brackets, so I'm going to distribute it through. So 2 times 5y is 10y. Okay, 2 times negative 6 is negative 12. And then I'm just going to copy the rest of the equation down. Plus 3y equals 14. Now I'm going to combine or collect my like terms. So 10y and 3y go together. I get 13y minus 12 equals 14. Okay, I can add the 12 to both sides. So negative 12 and positive 12 cancel each other out. So I get 13y equals 26. Divide both sides by 13, which means that y equals 2. So here in this example, we know that y equals 2. Okay, now I need to figure out what x is. So I've got two options. I can either replace this y equals 2 right here in for um, the first equation or my second equation. It does not matter. So I'm going to take my second equation simply because the x is isolated, but either way, it will still give you the exact same solution if you did it correctly. So I'm going to write down my equation, x equals 5y minus 6, and I know that y equals 2, so I am going to substitute in that y equals 2 right here. So this is going to say x equals 5 times 2 minus 6. So I get x equals 5 times 2 is 10 minus 6, so x equals 4. So here I know x equals 4, y equals 2, so that means that my solution, my answer that satisfies both equations is 4, 2.